Hello class, so let's continue with our process scheduling algorithm, and we'll be talking at one scheduling algorithm called preemptive scheduling algorithm, and the last one that we had spoken was on preemptive shortest job first scheduling algorithm. Then we'll look at round robin scheduling algorithm. Now this is concept as a time sharing scheduling algorithm or a preemptive scheduling algorithm because of the reason that it gives each process access to the CPU for a certain time quantum or time slice. Okay, for example, it could be 26 milliseconds. Okay. Now, when such a process are being given, sometimes it may block itself before its time slice. Okay. And when the process starts executing and utilizing the CPU service, its time slice will expire. Okay, if it uses, its time spent in the CPU will be expired if it uses its entire time slice. And then what happens that it is preempted and put at the end of the queue. By this it means that if within that time quantum, if it is not able to run into completion, then it's being put back to the end of the ready queue. Now the ready queue is treated as a first in first out queue and treated as a circular, which means that this is an ongoing queue. Now if there are n processes on the ready queue and the time quantum is q, then each process get 1 by n time on the queue in chunks of most queue time units. Okay. Now no process waits for more than n minus 1 queue time units. Now the choice of how big to make the time slice or quantum is extremely important. If time quantum is very large, then round robin degenerates into first come first serve. But if time quantum is very small, the context switch overhead benefits the more, okay, than the time that the process can spend inside the CPU. Now in round robin, like I told you, each process will be given a time interval or time quantum. Okay. Now switching requires a certain amount of time, and that is used up. So that's why the choice of queue is very important. Okay. Because during switching, these are the things that happen. So it's saving and loading of registers of the intended process. The memory maps is to be adjusted, updating various tables, flushing and reloading the memory cache. Now suppose if it's a 4 millisecond quantum, then there will be 1 millisecond overhead involved, and if it's a 100 millisecond quantum, and you have a 1 millisecond overhead. Now if quantum is longer than CPU burst, then preemption rarely happens. Now this is an example how round robin works. So you have 5 processes B, F, D, G, A, and according to this, B is right in front, followed by F, followed by D, followed by G, by A. Now suppose if round robin picks up process B for executing, it will run for some time. Now as soon as the time elapses, it goes back to the queue. Okay, at the end of the queue, and next process F is being picked up for execution. Okay, so let's demonstrate how to calculate turnaround time, wait time for processes that are executed in round robin. Okay, so consider this example here. So I have round robin scheduling implemented on 3 processes, 1, 2, 3, and the burst time is 3, 4, 3, and they arrive at the same time. Okay, and the time quantum is 1. Okay, so in the ready queue, okay, first process is 1, followed by process 2, followed by 3. Okay, so this is the ready queue. Okay. Now, so let's draw the Gantt chart. Okay. So as soon as the CPU is available, the first process will start executing at 0, and the first process is process P1. So let's execute. Now what is its burst time? It is 3. So let's start executing. So let's run from 0 to 1 minute. Now as soon as it does that, okay, we'll see that its time quantum is 1, so it is able to run only 1 minute. Okay, so as soon as that is being done, P1 will be stopped from executing. Okay, so its burst time is 3, right? So 3 minus 1, this will give us 2. That means that P1 has remaining 2, but it cannot run further because time quantum has elapsed because it has only one. So from 0 to 1 it has utilized the entire 1 minute. The next will run process P2. Now process P2 will run, okay, and will run up to the second minute, okay. Then in the second minute process P2 will stop, okay. So it will be 4 minus 1 equal to 3, okay. The next will run next P3, because the reason that P2 has given for only 1, and that is the time given for it, so it will be put back to the end of the queue. The next P3 will run and run for 1 minute and will stop at the 3rd minute. And P3, its running time is 3, no? So it will run for 1 minute, so it has remaining 2. Now again the round robin shilling will then again pick up process P1, will allow it to run for 1 minute, okay. So earlier it has 2 minutes, okay, so it will be 2 minus 1, okay, and this will give us, it has remaining 1. And who will run next? It will be process P2, okay, because from the queue we pick up according to that. So P2 has remaining 3, so it will run up to the 5th minute. So P3 has finished 1 more minute, so last it was able to complete was 3, so 3 minus 1, this will give us 2. And who will run next is P3, so it will run for 1 minute, okay. And P3 was able to run last and was able to complete 1 minute, so it has remaining 2, so 2 minus 1, this will give us 1. Now next process P1 will run again, so P1 will run, it has how many minutes? Only 1 more minute, P1 is equal, right? So it will run and it has run into completion. Next process P2, okay, it will run again, so it will run for 1 more minute. It has how much? P2 has 2 minutes more, okay, so it will run. So P2 has 2 minus 1, this gives us 1 more minute left, and for P3 it has only 1 more minute, which is this one, so run and complete in the 9th minute. Then next P2 will run again because P1 has finished, P3 is finished, only P1 is left, so run and it will finish the 10 minutes, okay. So this is the execution history for each of these processes using round robin with time quantum of 1, where it take turn to run 1 minute each, okay. Now let's calculate waiting time for process P1. Waiting time for P1, okay. So P1, when it started to execute initially, it doesn't have to stop, so it's 0. Then after that it stopped at the 1st minute, and then when is it allowed to run again? It is allowed to run again in the 3rd minute. So the next partial waiting is the time it was allowed to run minus by the time it was stopped. So it was stopped at the 1st minute, so 3 minus 1. Then next again it run and it stopped at the 4th minute, and then when is it allowed to run again? In the 6th minute. So again time it was allowed to run minus time it last stopped. This gives us 0 plus how much? 0 plus 2 plus 2 equal 4. Okay, so that is waiting time for process P1. Now process P2, okay, the first time that it was allowed to run, it was allowed to run in the 1st minute, so it has to wait for 1 minute. So initially it wait for 1 minute, then after that it stopped at the 2nd minute, and when is it allowed to run again? In the 4th minute. So time it was allowed to run again minus time it was last stopped, okay, and plus when is it then it run in the 4th minute and it stopped in the 5th minute, and when is it allowed to run again? In the 7th minute. So 7 minus 5 plus, then next it run again in 7 minutes, and it will stop in the 8 minutes. And when is it allowed to run again? In the 9 minutes. So it will be 9, the time it was allowed to run again, minus, and it was last stop. Okay, so you can see from here, from this execution history. Okay, so this gives us 1 plus 2 plus 2 plus 1. So 4 minus 2 is 2, 7 minus 5 is 2, 9 minus 1 is 1. So this will give us 1 plus 2 plus 2 plus 1, this will give us 6 minutes. Then waiting time for process P3. So this one, let's calculate. So the first time process P3 was allowed to run, it was running in the second minute. So that means that initially it has to wait for 2 minutes, then it stopped in the 3rd minute. Then when is it allowed to run again? It was allowed to run again in the 5th minute. Okay, so 5 minus 3. Okay, then it stopped in the 6th minute. When is it allowed to run again? In the 8th minute. Then plus, okay, it stopped, it was allowed to run in the 8th minute, minus 6, and this gives us how much? 2 plus 2 plus 2 3 6. Okay, now so let's fill up here. What is the start time for process P1? 0. Start time for process P2, 2. Oh sorry, 1. And process P3 is 2. What is the finish time for process P1? Process P1 was able to finish in the 7 minute. Okay, process P2 was able to finish in the 10 minute, and process P3 was able to finish in the 9 minute. Okay, so let's calculate now turnaround time for process P1. Now according to the formula, process turnaround time is finish time minus arrival time. Sorry, finish time minus start time. If you recollect, okay, let's recollect the calculation here. Okay, so you're going to see turnaround time is finish time minus arrival time. So finish time minus arrival time. Okay, so here process P1 only 7, 10, and so now we just calculate the average. Okay, so average for average of turnaround time, average equal to 7 plus 10 plus 9. This will give us how much? This will give us 26 divided by number of process. So this will give us 8.6. Okay, and then average waiting time, the waiting time for process P1 is how much? 4 plus waiting time of P2, 6 plus 6 of P3. This gives us 16 divided by number of processes 3, and this gives us 5.3. Okay, so this is the calculation. Okay, so this is how you calculate the average turnaround time, wait time to each process, and then the what you can say, the average turnaround time and average waiting time for each of the process. Now there are some exercises, for example this one, how to get these values, then for this one and this one. Now I want you to solve using round robin scheduling how to get these values. So you have to draw the Gantt chart and fill up the turnaround time for each of the process, waiting time, and all these things. Okay, so this is about round robin scheduling. Thank you.